Hi everyone, welcome to the parametric modeling tutorial using the SkyCiv Excel plugin. I'm Daniel Vivas, Product Manager of SkyCiv Engineering, and in this tutorial I'll guide you through the process of parametric modeling of a tank using the Excel plugin. Remember that you can find more information about the SkyCiv plugins and many more topics in our documentation. So let's get started. The first thing that you have to do is scroll down to apps and plugins, click here on Excel plugin, and you can get the SkyCiv for Excel plugin. You can download it and install it. Once it is installed, you will see a SkyCiv tab on Excel. You can see here different buttons that will perform different actions. So the first thing that we will do is configure our account. So we just have to type our username here, and we have to provide our API key. So if you don't know where to find this API key, you just have to click here. You have to log in. So you just have to copy this API key, go back to Excel, paste the API key, and click on Authenticate. Now that we authenticate, we can also modify these model settings. If you want to modify this vertical axis, or you want to change this unit system, you can do it here. In this example, we'll be working on the metric system, and we'll leave these units like this. Let's now create the template for editing our model. We just have to click here on Setup. This will open a new template, and here we can modify the notes, informations, members, section, materials, and many more information about our model. If you click here on Render, this will open a renderer where we'll be able to see all of the changes that we make in this template reflected in the renderer. So we will leave it open for this example. If I introduce two nodes, in this case I'll define the first node, the 0, 0, 0 coordinate, and the second one, the 0, 1, 0 coordinate. You should see two nodes reflected on the renderer. Now we are going to use this sheet to put all of the parametric modeling calculations of our tank. So I'm gonna rename this with tank design. We will use these input values to calculate our tank. So we have the ratio, the height, the water density, the gravity, and the pressure. This pressure will be calculated with the height by the density by the gravity, and we are going to divide this by 1000, so we are going to obtain this result in kilopascales. Let's find the coordinates for our tank. So in this case we're going to calculate the coordinates every 10 degrees. We're going to find the coordinates for 36 points. We are going to find the coordinates with the following formulas. So the x coordinate will be calculated with the ratio by the cosine of the angle. Z will be calculated with the ratio times the sine of the angle. And remember that our vertical axis is y. So we will start with a value of 0. I'm gonna define in these left cells the y value of these coordinates. So I'm gonna combine all of these cells, and I'm gonna use this formula to calculate the y value. Let's complete these fields with the formulas that we just created. Now let's see our result in the renderer. So I'm gonna go to the SkyCiv template. I'm gonna say that this field will be equal to x. Let's define 36 points. And this is the result that we are obtaining. I'm gonna hide the node IDs so this will move faster. Let's continue creating more nodes in the y-axis. I'm gonna repeat this process by creating more nodes in the y-axis. So I'm just gonna use this formula and I'm gonna increase this number until I finish with 4. That way we'll create many circles using this height. I'm gonna modify this value. Let's put in here 1, and then I will say that this will be equal to this field. I'm gonna fix this, and I'm gonna assign this to 36 points, and I'm gonna repeat the process, and I'm gonna assign this value to 36 points until I complete the height of 15. As you can see, we also increased this angle in the previous step. So if you want, you can start this from 10 to 360, but as this is a circle, this will be equivalent, so you will obtain the same values. Now that we have more circles in the y-axis, let's see our results in the renderer. So let's go back to the SkyCiv template, and I'm just gonna drag this field. And you can see the result for all of our circles. So as this is a parametric design, if I modify these values right here, if I modify let's say for example 16 and the height will be 10, these values will automatically change, so this result will change as well. It can take a couple of seconds until the renderer shows the new results. So these are our new results. So now we have a parametric way to define our coordinates. Let's now define our materials. So in this case, I'm gonna go to materials. There are some cases where you don't know what information to put here. In this case of the coordinates, it's very easy to know that we just have to put numbers, but in this case it's more complex. That is why we offer this documentation. You just have to click here. This will open a new window, and here you have the documentation. So if you go, for example, to materials, this will explain what values you should put on each field. In this case, I'm gonna use the following values, and the class will be, and that's it. Let's now define our plates. So I'm gonna go to tank design. I find my plates. This will be the plate IDs. We're going to define 144 plates. And here I will define the nodes. As you can see, we will create the plates following this pattern. So from node 1, 2, 38, 37 will be the first plate. So you can use this formula I'm just using this concat function. I'm using the plate ID number 1, number 2, and then I'm using node number 2, and I'm adding 36 to this number. So if you remember, we are always defining all of our parametric design with 36 points. That's why I'm using this. And the last one will be 35, so we can obtain this value. So if I do this, we can reuse this formula until node 35. But if you see here, we have something to do with this last plate. So the algorithm for that one will be where we are going to use this value together with the first one, and to the last value we are gonna add 1, and the last one, the last value plus 36. This is how we are going to create this last plate. So you can see that this will give us nodes 36, 1, 37, and 72. So we are going to use this algorithm that we just created to fill these empty fields that we have until cell 140. Let's see the result in the renderer. So if we go back, we can, I'm gonna close these materials. I'm gonna open the plates, and here we can say that this will be equal to this field. The thickness, I'm gonna use 5, and the material ID, I'm gonna use this ID that we just defined here, ID number 1. In this rotation, I'm gonna leave a value of 0, and the type will be auto. Remember that if you don't know what to put here, you can always open the docs. So now I'm gonna drag this cell, and this will be the result. As you can see, we can also define a new ratio, for example 4. I'll say that the height will be 20, and we just have to wait until the renderer show us the new shape of the tank. Let's now define the pressures for our plates. Here, pressures, this will be X magnitude, Y magnitude, and Z magnitude. In this case, all of the pressures will be applied in the Z magnitude. The local axis will have the Z magnitude perpendicular to the plates. So we will use the following formula. So this will be calculated using this total pressure. So we'll be use the equivalence taking into account the height of the plate. So you can use this formula. These values will be always 0, and with this we can just double click, and we have to modify this height in this plate. So I'm gonna repeat the process with all of these heights. I forgot to mention that we haven't created the plate at the bottom of the tank, so we have to define first an origin. So in coordinate 0, 0, 0, I'm gonna put here origin. I'm gonna drag this. I'll put an ID of 999. This should create a node right in the middle. Also, we have to define the plates. So I'm gonna write here circular plate. You can see here the new node that we are creating. If we use this formula, if you remember, we have to use from node 1 to node 36 in order to create the plate at the bottom of the tank. So create more IDs, and I have to define from node 1, and this will be, I'm gonna use this, and the last one will be from node 1 to node 36. We go back to the template, we can go to the plates, and we can drag this information until the plate ID 180. So this should create the plates at the bottom of the tank. Just have to wait for the renderer to see the result. And that's it. You can see now that we have these plates created at the bottom of the tank. Let's put the pressures that we just calculated in the SkyCiv template. So we just have to go to, I'm gonna close these plates. We can go to pressures. I'm gonna open this. Remember to check the documentation to know what to put here. I'm gonna use these IDs. Actually, these IDs will be the same until 144. The axis, I will use local axis. This magnitude will be equal to this magnitude. Drag this, and the load groups, I'm gonna put a water pressure. Let me drag this, and I'm gonna replicate these fields 144 times. Now that the information of the pressures is replicated, I'm gonna define the supports for the tank. So I'm gonna go back to tank design. I'm gonna create here my supports, node ID, and the restraint code. If you don't know what is this restraint code, you can go to the documentation, supports, and if we go here to restraint code, you will find more information about this. So we just have to define these fixities for each support. In this case, I'm gonna define node supports for my 36 nodes at the bottom. So I'm gonna create 36 nodes, and the restraint code will be fixed. This is the way how we define fixed support. So I'm gonna go back, I'm gonna open these ports. This will be equal to this. Actually, this is also gonna be equal to this. And I'm gonna drag this restraint code. I had to activate this function in the display items to check my supports. So you can see them here. Now that everything is finished, we can proceed to open this model in S3D. We just have to click here on Open in S3D. This will take a couple of seconds to open a new window. And you will see that this structure is now working on S3D. So as you can see, we have all of our plates, the nodes, the restraints. We also have these pressures, as you can see. And the idea with this plugin, with this Excel plugin, is that you can define a parametric design. So I just have to modify these two values, and the tank will automatically modify the dimensions, the pressure, everything. So it is a good idea to use these plugins when you have to do repetitive tasks, so you don't have to go to S3D and redefine your model manually. So I'm going to show you an example. If I define, let's say, 5 and a height of 25, you can see how all of these values will change. So all of these values in the SkyCiv template will change, and we'll have a new model. So if I open this again in S3D, I should see my results. So you can see how easy it is to modify this tank directly from S3D using the parametric modeling. So let's go back, define the ratio of 4 and the height of 7.3. We'll have this pressure. So let's open this in S3D. And let's solve our structure. Actually, we have to mesh the plates, so I'm gonna select all, do right click, mesh plates, and mesh. This will take a couple of seconds to generate the mesh for all of our plates. We can go to File, save this project, and use walkthroughs. I'm gonna say Parametric tank design modeling using Excel plugin. I'm gonna save this. And if we go to the platform, I'm gonna refresh this page. You should see here the file, so you can actually now work from your SkyCiv account. So now let's solve our structure. And here you can check all the results for the tank. I'm pretty sure that you can do better examples using this parametric modeling. Also, if you know how to program, it'll be a good idea to take a look at the API from SkyCiv, since you can create different programs, different algorithms to create these parametric modeling and design. You have completed the parametric modeling tutorial using the SkyCiv Excel plugin. I hope this tutorial has provided you with valuable insights into the process of modeling repetitive structures using the Excel plugin. If you have any questions or need assistance, our team at SkyCiv Engineering is always here to help. Thank you.